In this question, we have to find value of this determinant, and for simplification, let's add second row in the third row. So we will get x plus y plus z in each element of the third row. So preferable operation is R3 gives R3 plus R2. That means we have to multiply first one, the second row, and add into the third row. So x ones are x, y ones are y, z ones are z. This operation over first and second row will be as it is, and our third row become x plus y plus z, x plus y plus z, and x plus y plus z. Now we can divide third row by x plus y plus z. So we have to multiply x plus y plus z with the determinant, and third row will be 1, 1 and 1. Rest of the two rows will be as it is, right? Here you can see our first row is same as third row. So simply the value of determinant will become 0. Ta-da! Value of determinant is 0. Option C is your final answer. In this question, we have determinant is equal to k, x minus y, y minus z, and z minus. We have to find the value of k. So first of all, let's begin from the left hand side. And here we have our determinant. In first row, we have 1, 1 and 1, which will helpful to get 0 using column operation. And one more thing, to get x minus y as a factor, it's preferable that we subtract first column and minus second column. So we have to multiply minus 1 with the second column and add into the first column. You will get 1 minus 1 minus 1, y minus y minus y, and zx minus 1 minus zx. Same thing we can do for getting y minus z. We can take C2 gives C2 minus C3 operation. So multiply third column with minus 1 and add into the second column. So 1 minus 1 minus 1, z minus 1 minus z, similarly xy minus 1 minus xy. So our modified first column will be 0, x minus y. After taking minus z common, we will get x minus. Now second column 0, y minus z, and after taking minus x common, we will get y minus z. Third column will be as it is. Now we are ready to divide first column by x minus y. So we have to multiply x minus y with the determinant. Our first column will become 0, 1 and minus z. Same thing we can do with the second column. Second, we can divide y minus z. We have to multiply y minus z. The second column will be 0, 1 and minus x. Third column will be as it is. So our x minus y and y minus z factors will be as it is. We just have to expand determinant with respect to first row. So the sign of the first row, plus, minus and plus, and their respective elements are 0, 0 and 1. We don't have to worry about the minor of 0 and 0 because 0 into anything will be 0. Let's find out minor of 1 by ignoring first row and third column. Multiply minus x with 1 plus minus x minus minus z with 1 plus z. So finally x minus y will as it is, y minus z will as it is, and here we'll get z minus x. And we have to compare this with our right hand side. So here we will get k is equal to Ta-da! Option A is your final answer. In this question, it is given that determinant is equal to k, x minus y minus z and z minus x. And we have to find the value of k. So first of all, let's get our left hand side. In first row, we have 1, which can easily converted into 0 by taking column operations. And to get x minus y factor, preferable operation is c1 gives c1 minus c2. So let's multiply second column with minus 1 and add into the first one. 1 minus 1 are minus 1, y minus 1 are minus y, and minus 1 plus y the whole square. Similarly, to get y minus z factor, let's do c2 gives c2 minus c3 operation. For that, you have to multiply third column with minus 1 and add into the second column. Here we'll get 1 minus 1 are minus 1, then minus z and minus 1 plus z the whole square. So our first column will be 0, x minus y, and for last element, if we apply the factor of a square minus b square, which is a minus b and a plus b, we will get x minus y and x plus y plus 2. Similarly, the second column will be 0, y minus z and y minus z, y plus z plus 2. And third column will be as it is. Now we can divide first column by x minus y. So we have to multiply the determinant with x minus y. And our first column will become 0, 1 and x plus y plus 2. Similarly, we divide second column by y minus z. So we have to multiply the factor y minus z with the determinant. The second column will be 0, 1 and y plus z plus 2. The third column will remain as it is this step. Now on, for x minus y minus z factor will be as it is, and our determinant should be expand with respect to first row. Their signs are plus, minus and plus. Their elements are 0, 0 and 1. We don't have to worry about the minor of 0 and 0, because 0 into anything will be 0. So let's find out minor of 1 by ignoring first row and last column. Y plus z plus 2 ones are y plus z plus 2 minus x plus y plus 2 ones are x plus y plus 2. So here x minus y minus z still remain as it is, and we will get our third factor by cancelling y and 2. Here we'll get z minus x, right? So let's compare our result, the right hand side which is given in the question, and by comparing we will get k is equal to 1. Ta-da! Option A is your final answer. This question, we have to find the value of x which satisfied our determinant equation. Simplify this. Let's collect all the elements in any one row or column. I prefer all elements collecting first row. So we must take operation R1 give R1 plus R2 plus R3. So let's add second row first by multiplying 1. So here we'll get a minus x ones are a minus x, a plus x ones are a plus x, and a minus x ones are a minus x. Same thing you have to do with the third row. A minus x ones are a minus x, a minus x ones are a minus x, a plus x 1 the a plus x. So our first row will become a plus 1x cancel out, we will get minus x. Same thing, second element and the third one. The rest of the two rows will be as it is. Now we can divide first row by dA minus x. So we have to multiply dA minus x with the determinant. Your first row will become 1, 1 and 1. Rest of the two rows still remain as it is. First row we get 1, which can be easily converted into 0 by taking column operation. Let's try to get 0 at A12 and A13 position using first column. So second column should be converted in second column minus first column. So we have to multiply first column with minus 1 and add into the second column. So 1 minus 1 is minus 1, a minus x 1 is minus a plus x, a minus x 1 is minus 1 is minus a plus x. Similarly, you can convert third column by C3 minus C1. Multiply minus 1 with the first column, add into the third column. 1 minus 1 is minus 1, a minus x 1 is minus 1 is minus a plus x, a minus x minus 1 is a plus x. So dA minus x and first column will be remain as it is. So second column will be 0. This AA will cancel out, x plus x will become 2x. AA and xx both will cancel out and they will get 0. And in third column get 0, AA as well as xx cancel out and get 0. And finally we will get 2x. Here we can say but a minus x as, and we get lower triangular determinant value can be obtained by multiplying its principal diagonal elements. So 1 in 2x to 2x is equal to 0. So this will give us different factors. A minus x is equal to 0 and 4x square is equal to 0, which suggests that value of x must be EA or 0. So tada! Option D is your final answer. In this question, you have to find value of x which satisfied our determinant equation where A is not equal to B is not equal to C. So first of all, let's write down our determinant equation, and here we have further simplification is not possible. So let's expand with respect to first row. So let's write down the elements of the first row with their respective sign. Plus 0, then minus x minus a, then plus x minus b. Okay, now it's time to find the minor. We don't worry about the minor of 0 because 0 into anything will be 0. So let's get the minor of x minus a by ignoring first row second column. 0 will multiply with x plus a to give us 0 minus x plus b will multiply with x minus c will give us x square minus xc plus bx minus bc. Then minor of x minus b. Ignore first row last column and multiply x plus c with x plus b will give us x square plus xc plus xa plus ac, and anything with 0 will give us 0. Okay, now it's time to open all the brackets. Let's talk about the first term. This minus minus become plus. Now multiply x with each element with this x cube minus x square c plus bx square and minus bcx. Now let's multiply minus a. So here we'll get minus ax square plus axc minus abx and plus abc. Now let's simplify the second term. Similarly, we will get x cube plus x square c plus x square a plus acx minus bx square minus bcx minus abx and minus abc is equal to 0. Now let's simplify. X cube plus x cube will give us 2x cube. Then collect the terms of x square. X square c will cancel out. bx square will cancel out. ax square will cancel out. Now let's collect the terms of x. Minus bcx will give us minus 2bcx, then minus abx and minus abx will give us minus 2abx, and finally acx plus acx plus 2 times acx. abc minus abc will cancel out. So here we get our simplified form. We can take 2x common. So here we'll get x square minus common from the rest of the term. We get bc plus ab plus ac is equal to 0, which suggests that our x may be 0 or under root of bc plus ab plus ac, and we have x is equal to 0 in option A. So tada! A is your right answer. In this question, we have to find the value of this determinant. So first of all, let's write down the determinant, and here it is. Before we expand, let's try to get maximum 0 as possible. Let's begin with the K11 position by taking difference of first row minus second row and minus third row. So our operation will be R1 gives R1 minus R2 minus R3. So let's multiply minus 1 to the second row and add into the first row. So P minus 1 are minus P, C plus A minus the minus C minus A and minus P. Now let's multiply minus 1 to the third row and add into the first row. So minus C and minus A minus B. So here our second and third row will be as it is. Let's write down as it is. Our first row will be BB and CC cancel out, get 0 as the plan, and here AA will cancel out, we will get minus 2C. Again AA will cancel out and we will get minus 2B. Now here we can further simplify by taking minus 2 common from the first row. So our operation will be R1 gives 1 by minus 2 R1. If we are dividing minus 2 to the second row, we also have to multiply minus 2 with the determinant. First row will be 0, C and B, and second and third row will be as it is. Further simplification, we have to take minus first row, second and third row. So our operations will be R2 gives R2 minus R1. So let's do this process. We have to multiply minus 1 with the first row and add into the second row. So 0 minus 1 are 0, then minus C and minus B. Same thing we can do with the third row. R3 gives R3 minus R1. Multiply minus 1 and add into the third row. So minus 0, minus C and minus B. In this process, our first row will be as it is, minus 2 will also as it is, and your second row will be B A and 0, and third row will be C, 0 and A, right? It's preferable to open with respect to first row. So let's expand. Just write down their elements: 0 bracket minus C bracket plus bracket. Now let's try to find minor of A's. Multiply A with A will give us A square, minus 0 with 0 will give us 0 square, or we can say 0. Now next minor is obtained by multiplying A with B, AB minus C with 0, 0, and the last one, 0 B's are 0 minus C is a AC. So here we'll get minus 2 minus ABC minus ABC will give us 4 times ABC. Ta-da! Option D is your final answer. We have to find roots of this determinant equation. Now let's try to get maximum 0 as possible. We can get 0 over here by taking operation R1 gives R1 minus R2. That means you have to multiply minus 1 to the second row and add into the first one. So 1 minus 1 is a minus 1, then minus 1 minus x and minus 1. Same thing we can do to get 0 over here. Let's take another operation of R2 gives R2 minus R3. That means let's multiply minus 1 to the third row and add into the second one. So 1 minus 1 is a minus 1, then again minus 1 and minus 1 minus x. So in both process our third row will be as it is. So as it is, then first row will be x, 1 cancel out, minus x, and we will get 0 over here. And the second row will be 0 x and minus x. So you should observe that we can take x common from the first as well as second row. So let's do the fourth operation. Let's divide first row with x. So we should multiply x to the determinant, and our first row will be 1 minus 1 and 0. Same thing can be happen with the second row. So further we have to multiply x to the determinant, and second row will be 0, 1 and minus 1. Our third row will be as it is equal to 0. Now we are ready to simplify. This x into x will give us x square. Let's expand determinant with respect to first row. So their elements are 1, then minus 1, and finally plus 0. Now let's find out their minors. Minor of first element is obtained by eliminating first row, first column. 1 plus x, 1 is 1 plus x, minus 1 with minus 1 will give us minus 1. Then minor of minus 1, 1 plus x, zeros are 0, minus 1 minus 1 is minus 1. And don't worry about the minor of 0, 0 into anything will be 0. So if we simplify this, we will get x square as it is. Here we will get x 1 plus 1 plus 1 plus x plus 3 is equal to 0. This x square equal to 0 will give us two same roots. X is equal to 0 and x is equal to 0. This x plus 3 will give us x is equal to minus 3 as the one root. Option B is your final answer. Now let me remind you something. number of roots should be equal to number of polynomial, and if we expand this determinant, you can see you will get multiplication of 1 plus x into 1 plus x into 1 plus x, which suggests that order of polynomial will be 3. So there must be 3 roots, which is only in option B. So B is the most promising option, right? So without simplification, you can get the correct answer. Ta-da! In this question, we have one determinant which is equal to k a square b square c square, and we have to find the value of k. So let's begin our left hand side. Here it is. Now our simplification can be begin with the fourth operation. We can take a, b and c from the first, second and third row. Let's do the operation. R1 gives 1 by a r1. Now if we are dividing a with the first row, we have to multiply a with the determinant. So our first row will be minus a, b and c. Now same thing with the second row. R2 is divided by b. So we have to multiply b with the determinant. Your second row will be a minus b and c. Similarly, your third row will give us c, a, b and minus c. Now let's try to get maximum 0 as possible by adding first row to the second row. So our operation will be R2 gives R2 plus R1. That means we have to multiply 1 and add into the second row. So minus a, 1s are minus a, then plus b and plus c. So in this process, our first and third row will be as it is. So just write down as it is, and your second row will be a minus a 0, minus b plus b 0, and here we'll get 2c. Now if you want to take abc common, you can take common, or simply expand with respect to second row. This abc will be as it is, and elements of the second row are minus 0, plus 0 and minus 2c. We don't have to worry about the minor of 0 and 0 because 0 into z anything will be 0. So let's find out minor of 2c by ignoring second row and third column. Now let's multiply b with minus a, will give us minus ab, then minus a with b will give us ab. So here we will get this abc will as it is, minus 2c minus ab will give us minus 2ab, or finally we will get 4a square b square c square. Let's compare with the right hand side, which is k a square b square c square. So here we'll get k is equal to 4. Ta-da! Option C is your final answer. In this question, you have to find value of this determinant. Now let's eliminate this 1 by a, 1 by b and 1 by c by multiplying a with first row, b with second row and c with third row. So if we are multiplying a with the first row, we have to divide with the determinant. So your first row will be 1 abc and a raised to 4, then 1 by b, 1 abc, b raised to 4, and similarly 1 by c, 1 abc and c raised to 4. Now as you can see, we can take abc common from the second column. So let's apply. C2 gives 1 upon abc, c2. So if we are dividing second column with abc, you have to multiply ABC. So A and C will cancel out, and first and third row will be as it is, and your second column will be 1, 1 and 1, right? This ABC cancel out, but as you can see, first column and second column are equal to each other, and whenever two columns or row will equal to each other, then your determinant is simply 0. So ta-da! Option A is the final answer. Let's see the next question. If ABC are pth, qth and rth term of AP, that means we can say A is equal to TP, or we can say capital A plus P minus 1 T. Similarly, B is qth term, so we can say A plus Q minus 1 T, and C is the rth term, so here we'll get A plus R minus 1 T. Then we have to find value of this determinant. So first of all, let's place the value of A, which is A plus P minus 1D, or we can say PD minus D. Similarly, the value of B and C can be used respectively, and rest of the terms will be as it is. Now let's try to simplify. Here we have P, Q and R with the multiplication of D, which can be eliminated by taking operation. C1 gives C1 minus DC2, or we can say we have to multiply minus D to the second column and add into the first column. So P into minus D will give us minus PD, then minus QD and minus RD. Similarly, we can remove A and minus D, which are the constant terms, by taking C1 gives C1 minus A minus D C3. That means we have to multiply minus of A minus D, or we can say minus A plus D, with the third column and add into the first column. So here we'll get minus A plus D, minus A plus D and minus A plus D. Now let's simplify our first column. Here A, B, D and PD will cancel out. So here we'll get 0. Similarly, 0 and 0. Now rest of the two columns will be as it is, and our first column is equal to 0. So the value of determinant will be 0. Ta-da! Option C is your final answer. In this question, you have to find the value of this determinant. Now, let's simplify to get the value. First of all, in first and third column, we have common factor as a ABC, which can be simplified by operation C1 gives C1 minus C3, or we can say we should multiply minus 1 third column, add into the first column. So here we'll get A minus 1 the minus A, minus B and minus C. Now let's compare second and third column. You should observe that the missing element of A plus B plus C in second column is in the third column. So we can say C2 can be converted into C2 plus C3. That means you have to multiply plus 1, add it to the second column. So here we'll get plus A plus B and plus C. So our modified determinant will be a cancel out, we'll get minus b, minus a and minus a. And our second column will be a plus b plus c, a plus b plus c and a plus b plus c. And third column will be as it is, a, b and c. Now you can divide a plus b plus c with the second column easily. So if we are dividing 1 upon a plus b plus c, the second column, you have to multiply with the determinant. So our first and third column will be as it is and second column will be 1, 1 and 1. Now this one will be helpful to get 0, which will be useful to simplify the determinant, right? So let's use the third row to get the zeros in the first and second row. So first row can be changed by r1 minus r3. So we have to multiply third row with minus 1 and add into the first row. So we'll get plus a, minus 1 and minus c. And same way we can do with the second row, gives second row minus third row. So we have to multiply minus 1 the third row and add into the second row. We'll get same quantities, plus a, minus 1 and minus c. So our simplified determinant will be a plus b plus c will as it is, and third row will be as it is. First row will be a minus b, then 0 and finally a minus c. And second row will be 0, 0 and b minus c, right? Now we just have to expand the determinant with respect to second row. This a plus b plus c will be as it is, and the sign of the second row is minus, plus and minus, and their elements are 0, 0 and b minus c. We don't have to worry about the minors of 0 and 0. We just have to find out minor of b minus c by ignoring its second row and its third column. Let's cross multiply. 1 with a minus b will give us a minus b, minus a with 0 will give us 0. Let's multiply this minus 1 within the bracket and we will get a plus b plus c into c minus b into a minus b. Ta-da! Option D is your final answer. In this question, we have to find the value of this determinant. Before we simplify it, let's simplify the terms. As you can see, we can take b common from the first term. So let's take b common and remaining terms are b minus a. Similarly, from the next term we can take a common. So again we will get b minus a. The last term of the first column we can take c common. So we will get b minus a. Second column will be as it is. Now it's time to simplify the third column. Take c common, we'll get b minus a. Here we can take b common, again b minus a, and a common, get b minus a. Right? So from the first and the third column we can divide b minus a. So let's divide first column by b minus a. So we have to multiply b minus a with the determinant, and our first column will be b, a and c. Our second column will be as it is, and we can also divide b minus a from the third column. So let's divide b minus a from the third column. So we have to multiply b minus a. Our third column will be c, e and a, right? So we feel simplified first and third column. Now it's time for the second column. To remove first term of the elements of second column, we will use first column, or we can say, let's take C2 gives C2 minus C1, and to eliminate second term, we have to use third column. So let's take minus C3. So let's do this. You have to multiply minus 1 with the first column and add into the second column. So here we'll get minus B, minus A, and minus C. Same thing you have to do with the third column. We have to multiply minus 1 and add into the second column. So here we'll get minus C, minus B, and minus A. So in next step, our B minus A square will be as it is. First and third column will also as it is. And in third column, B cancel out, C cancel out, we get 0. Similarly, get rest of the terms equal to 0. So here our entire second column is equal to 0, which will suggest that the value of determinant is 0. Tada! Option D is the correct option. In our next question, we have to find number of distinct real roots of determinant equation. A determinant containing sin and cos equal to 0 in the interval of minus pi by 4 to pi by 4. In determinant, we have two different trigonometric terms, sin and cos, right? So it will be little difficult to handle them, right? So let's convert into the tans, okay? And for that, you have to divide by cos x, first, then second, and third row. So we are dividing 3 times cos x, so we have to multiply 3 times, or we can say cos cube x. Now our first row will become sin x by cos x will give us tan x, then cos x by cos x will give us 1, and again 1. Similarly, second row will be 1 tan x and 1, and the third column will be 1, 1, and tan x. Determinant is equal to 0. So here we get one symmetric determinant. So let's collect all the terms in any one row or column. Let's collect the first column. So our first column will be converted into C1 plus C2 plus C3. So first of all, let's add our second column. Actually here we multiplying with 1 and then add, but it doesn't matter. So let's add plus 1 plus 10x and plus 1. Similarly, it's time for the third column. Get plus 1 and plus 10x, right? Okay. Now cos cube x is not equal to 0, so we can divide by 0, so it will be 0, and our first column of the modified determinant will be tan x plus 2. Same factors we will get in rest of the elements of first column, and rest of the columns will be as it is, right? Okay. Now we can divide first column by tan x plus 2. So let's divide first column by tan x plus 2. So we have to multiply tan x plus 2 with the determinant. First column will be 1, 1, and 1. Rest of the two columns will be as it is, right? Now, before we simplify the determinant, let's get the as many 0 as possible. So I will try to get 0 at A21 and A31 position using first row. So the preferable operations are R2 gives R2 minus R1. That means we have to multiply minus 1 the first row and add into the second row. So here we'll get minus 1, tan x minus 1, and -1. Same thing we can do with the third row, R3 minus R1. So we have to multiply -1 to the first row and add it to the third row. So again we will get -1, -1 and -1. So our first row of the determinant will be as it is. Second row will be 0, 10x minus 1 and 0. And third row will be 0, 0 and 10x minus 1. So here we get upper triangular determinant 10x plus 2 will as it is. And the value of determinant can be found by multiplying principal diagonal elements 1 into 10x minus 1 into 10x minus 1 again. So here we get two different factors, 10x plus 2, actually three factors, but two distinct factors, right? So here we get 10x is equal to minus 2 and 10x is equal to plus 1, or we can say x is equal to tan inverse minus 2 and x is equal to tan inverse 1. But tan inverse minus 2 is not belongs to minus pi by 4 to pi by 4, but tan inverse x is equal to pi by 4 is belongs to close bracket minus pi by 4 to pi by 4. So we can say x is equal to pi by 4 is the only distinct root of our determinant equation. So tada, option C is the right answer. This question, you have to solve this determinant equation where theta is belong to 4 pi. We also have 4 theta. So say 4 theta is belongs to pi. Simplified determinant, we will try to get as many 0 as possible by taking difference between rows. Our first preferable operation is R2 give R2 minus R1. Multiply first row minus 1 and add it. Second row 1 minus sin square theta minus 1 are 1 sin square theta. Cos square theta minus 1 are cos square theta. 4 sin 4 theta minus 4 sin 4 theta. Similarly, let's operate R3 give R3 minus R1. Multiply first row with minus 1. Third row 1 plus sin square theta minus 1 minus sin square. Cos square theta minus 1 are cos square theta. 4 sin 4 theta. So in this operation our first row is remain as it is. Second row will be 1 cos square theta cancel out plus 1 cosine 4 theta minus cosine 4 theta. Similarly, third row will be 1 0 and 1. Now this determinant is look quite simpler. Let's expand first row. Their signs are plus, minus and plus. Their elements are 1 plus sin square theta, cos square theta, 4 sin 4 theta. Now let's find out their minors one by one. The first minor can be found by ignoring first row, first column. 1 will multiply with 1, 1 minus 0 will multiply with 0 plus 0. Now second element's minor is produced by ignoring first row and second column. 1 will multiply with minus 1, minus 1, minus 1, the 0. Finally, the minor of last element will be 0 minus minus 1 plus 1 is equal to 0. Let's simplify. 1 plus sine square theta, 1 is sine square theta, minus minus plus cos square theta. Okay, 4 sine 4 theta is equal to 0. Here sine square theta plus cos square theta, 1, okay, 1 plus 1. Take 4 sine 4 theta on the right side, plus minus 4 sine 4 theta. Here we'll get sine 4 theta is equal to minus 1 by 2, which is less than 0, and sine is negative only in third and fourth quadrant. Hence 4 theta must be pi plus pi by 6, or pi minus pi by 6. Finally, you can say theta must be equal to 7 pi by 24 or 11 pi by 24. Tada! Option A is your final answer. The determinant is looking quite similar as symmetric. So let's collect all the elements in any one row or column. Here I am going to collect all the elements in first column. So C1 plus C2 plus C3. So first of all, let's collect the elements of the second column. Multiply with 1 and add into the first column. So here we'll get x plus y plus x and x plus 2y. Then it's time to add the third column. So here we'll get x plus 2y, x plus y and plus x. So the first column of the determinant will become x plus x plus x, which is equal to 3x plus 3y. Similarly, second element will also 3x plus 3y, and same as third one. And rest of the two columns will be as it is. Now we can divide first column by 3 times x plus y. So we have to multiply 3 times x plus y with the determinant, and our first column will be 1, 1 and 1. Now rest of the two columns will be as it is. Here they are. Now we get 1, which will helpful to get maximum 0 as possible. So let's try to get 0 at A21 and A23. Let's use the first row. R2 gives R2 minus R1. So we are going to multiply minus 1 to the first row and add into the second row. So here we'll get minus 1 minus x minus y and minus x minus 2y. Same thing we can do with the third row. We will take R3 minus R1. So let's multiply minus 1 to the first row and add into the third row. So we'll get same minus 1 minus x minus y and minus x minus 2y. So in this operation, our 3x plus y as well as first row will be as it is. Then our second row will be 0, xx cancel out, minus y, xx and y minus 2y will give us minus y again. And third row will be 0, y and minus 2y. Right? So here we get 2 zeros in first column, which will helpful to find the value of determinant. Our 3x plus y will as it is. Let's expand with respect to first column. So their sign is plus, minus and plus respectively, and their elements are 1, 0 and 0. We don't worry about this 2 zeros and their minors, right? We just have to find minor of A11 by ignoring its first row and first column. So let's cross multiply. Minus 2y into y minus y will give us 2y square, minus y into minus y will give us plus y square, right? So here we will get 3y square into 3 will give us 9y square x plus y. Ta-da! Your answer is option B. In this question, we have f of x is equal to 1 determinant. Then we have to find f of 49. So first of all, let's try to simplify our determinant. And here it is. We can divide second column by x minus 1. So here we are going to take operation C2 gives 1 upon x minus 1 C2. So we have to multiply x minus 1 with the determinant, and our second column will be 2 x minus 2 and x are the remaining terms. Similarly, we can divide third column by x minus 1, x minus 2. So we have to multiply x minus 1 and x minus 2 with the determinant. Third column will be 3 x minus 3 and x. Our first column will be as it is. So our common factors will be x minus 1 square and x minus 2. We can further simplify our second row by first row taking plus r1. So simply let's add our first row to the second row. So here we'll get plus 1, plus 2 and plus 3. In this operation, our first and third row will be as it is, and second row will be x, x and x. And in this determinant, our second row is same as our third row. So we can say the value of determinant is 0. So for any value of x, our f of x will be 0, and f of 49 will also equal to 0. So tada! Option C is your final answer. In this question, we have to find divisor of this determinant, and for that, let's try to divide our first row by A. Using operation, R1 gives 1 upon A R1. So if we are dividing first row by A, we have to multiply A with the determinant. So our first row will become A square plus x square divided by A, then AB by A will give us B and C. Similarly, we can do with the second row. We can divide with B. So we have to multiply B with the determinant, and second row will be A, B square plus x square by B and C. And same thing we can do with the third row. Let's divide by C to the third row. So we have to multiply C. So here we'll get A, B and C square plus x divided by C. But as you can see, we get A, B, C in the denominator of the principal diagonal elements. We separate A, B and C, right? Here we have only A, only B and only C. So to use this opportunity and eliminate this A, we are going to multiply A with the first column. So we have to divide A with the determinant. So our first column will be A square plus x square, then A square and A square. Same thing we can do with the second column. We can multiply this B. So we have to divide by B with the determinant. Your second column will be B square, then B square plus x square and b square. And let's do this thing with the third column. Let's multiply c with the third column. So we have to divide c with the determinant. Here we'll get c square, and c square plus x square. Actually here we have x square, right? Okay. So by this two operation, we can eliminate ABC and ABC and separate A, B and C. Now here we have even distribution. So let's collect all the elements in any one column. So let's choose the first column. Add all the columns into the first column. First of all, let's add our second column. So here we'll get b square plus x square and plus b square. Now let's add our third column. So here we'll get plus c square and plus c square plus x square. So here our simplified determinant will have a square plus b square plus c square plus x square, and same quantity we will get in the rest of the two terms, right? Okay, and rest of the two columns will be as it is. Now as you can see, we can divide first column by a square plus b square plus c square plus x square. So we have to multiply this quantity with the determinant, right? So our first column will become 1, 1 and 1, and rest of the two columns will be as it is. So here we get 1, 1 and 1, which are helpful to get zeros. Let's use first row to get 0 using operation. R2 gives R2 minus R1. That means you have to multiply minus 1 with the first row and add into the second row. So 1 minus 1s are minus 1, then minus b square and minus c square. Similarly, we can get 0 in third row using R3 gives R3 minus R1. So we have to multiply minus 1 with the first row and add into the third row. So we'll get same quantities, minus 1, minus b square and minus c square. This factor will be as it is, and our first row will also as it is. Second row will be 0, x square and 0, and third row will be 0, 0 and x square. Here we get upper triangular matrix. This factor will be as it is, and the value of upper triangular matrix is simply multiplication of the principal diagonal elements. So 1 into x square into x square. So here we'll get a square plus b square plus c square plus x square into x raised to 4, which is actually divisible by x square. So tada! Option D is the final answer. In our next question, it is given that if x, y, z are not equal to 0, all are different numbers, and the value of this determinant is equal to 0, then we have to find value of 1 by x plus 1 by y and 1 by z. So first of all, let's get 1 by x, 1 by y and 1 by z. Let's divide first row by x. So we have to multiply by x with the determinant, and our first row will be 1 by x plus 1, then 1 by x and 1 by x. Same thing we can do with the second row. We can divide by y. So here we'll get 1 by y plus 1 and 1 by y. and same thing with the third row. Let's divide by z. So here we have to multiply y as well as z, and third row will be 1 by z, 1 by z, and 1 by z plus 1. Whole determinant is equal to 0. But we need summation of 1 by x, 1 by y, and 1 by z. So let's collect all the elements in any one row. Let's select first row. It gives r1 plus r2 plus r3. So let's add our second row in the first row. So here we'll get 1 by y plus 1 by y plus 1 and 1 by 1. Now it's time to add the third row within the first row. So 1 by z plus 1 by z and 1 by z plus 1. So xyz will be as it is, and our first row will be 1 by x plus 1 by y plus 1 by z plus 1. Same thing with the second and third element, and rest of the terms will be as it is. So here we can take 1 by x plus 1 by y plus 1 by z plus 1 common from the first row, or we can say we are going to divide by x plus 1 by y plus 1 by z plus 1 to the first row. So here xyz will be as it is, and the new common factor is 1 by x plus 1 by y plus 1 by z plus 1. Our first row will be 1, 1 and 1, and rest of the row will be as it is. So here we get our required factor. Now we just have to find the value of determinant. We have 1, which will helpful to get 0 by taking column operations. We are going to take C2 gives C2 minus C1, or we can say we are going to multiply minus 1 to the first column and add it to the second one. So here we get minus 1 by y and minus 1 by z. Same thing we can do with the third column, minus C1. So multiply minus 1 with the first column and add into the third column. We get minus 1 by y and minus 1 by z. So these two factors will be as it is, and our first column will also as it is. Second column will 0, 1 by y cancel out. We get 1, and in last term 1 by z cancel out and get 0. Now it's time for the third column. 0, 0 and 1 is equal to 0. Our common factors will be as it is, and we have lower triangular determinant, and its value is multiplication of principal diagonal elements. So let's multiply 1 into 1 into 1 is equal to 0. Now x, y, z are not equal to 0, which is given in the question. So we can say 1 by x plus 1 by y plus 1 by z plus 1 is equal to 0, which will give us 1 by x plus 1 by y plus 1 by z is equal to minus 1. So tada! We get our required answer. Option D is your final answer. In this question, we have to find the value of this determinant. Before we go for the simplification of determinant, we have to simplify the terms. Our first term is a raised to x plus a raised to minus x the whole square, which can be simplified as a square plus 2ab plus b square, or we can say the square of the first term give us a raised to 2x plus 2 times multiplication of the terms a raised to x into a raised to minus x plus square of the last term, which will give us a raised to minus 2x. As you can see, a raised to x and a raised to minus x can be cancelled out. So our first term will be a raised to 2x plus 2 plus a raised to minus 2x. Similarly, we can expand the second term as a raised to 2x minus 2 plus a raised to minus 2. And our last term will be 1. Same way, we can get the rest of the terms. Here they are. Now, we should notice that in first and second column, the only difference is this plus 2 and minus 2. We can eliminate this difference using column operation. To remove this plus 2, we have to take C1 gives C1 minus 2C3. That means we have to multiply third column with minus 2 and add into the first column. So 1 minus 2 is a minus 2, minus 2 and minus 2. Similarly, we can eliminate this minus 2 using C2 gives C2 plus 2C3. So our simplified determinant will be a raised to 2x plus 2 and minus 2 will cancel out, and we will get a raised to minus 2x, b raised to 2x plus b raised to minus 2x, and c raised to 2x plus c raised to minus 2x. Similarly, our second column will be a raised to 2x plus a raised to minus 2x, b raised to 2x plus b raised to minus 2x, and c raised to 2x plus c raised to minus 2x. Third column will be as it is, but you can notice that our first column is same as the second column. So we can say using third property, our value of determinant is 0. Tada! Option A is your final answer. In this question, you have to find the value of this determinant if x, y, z are greater than 1. Now, before we apply the rules of determinant or expand, first of all, we have to simplify using the properties of log. We are going to use the fourth property, change of base, to the each element of the determinant here. So our first row will be 1 will as it is log y base x can be rewritten as log y upon log x. Then log z base x can be rewritten as log z upon log x. Similarly, your second row will be log x upon log y 1 and log z upon log y. And third row will be log x upon log z, log y upon log z 1. Let's apply the fourth property to remove log x, log y and log z in first, second and third row. So we have to multiply log x to the first row, log y to the second row, and log z to the third row. So you have to divide by log x to the determinant because we are multiplying log x to the first row. So here we'll get log x, log y and log z. Same thing with the second row. Divide log y, multiply log y, and your third row, right? Okay, now as you can see, first, second and third row are equal to each other, and when two rows or n column will be equal to each other, then your determinant will be 0. So tada! Option C is your final answer. In this question, you have to find the value of this determinant. Before we apply the properties of determinant, we have to simplify second and third row using first property of log. Our first row will be, it is now first term of the second row, which is log 2 into x, can be rewrite as log 2 plus log x. Similarly, second element is log 2 plus log y. Third element we rewrite as log 2 plus log z. Now, third row's element can be simplified using same property as log 3 plus log x, log 3 plus log y, and log 3 plus log z. Right? So this is your simplified determinant. Now, we can further simplify this by taking log x minus from the second and third row. So, the preferable operation is R2 gives R2 minus R1. So here you have to multiply minus 1 to the first row and add into the second one. So here we'll get minus log x, then minus log y, and minus log z, because this is your log z. Same thing can be done with the third row, R3 minus R1. So multiply minus 1 and add into the third row. So same thing will happen with the third row, minus log x, minus log y, and minus log z. So here our first row will be as it is. So here we have as it is. Now the second row will be log 2. Log x will cancel out. Same thing, log 2 and log 2, the rest of the elements. Okay, and your third row will be log 3, and log 3. So we can take log 2 common from second row by taking operation R2 gives 1 by log 2 R2. So if we are dividing log 2 in the second row, you have to multiply log 2, the determinant. So your second row will be 1, 1 and 1. Same thing can be done with the third row. R3 gives 1 by log 3 R3. So here we have to multiply log 3 with the determinant. Your third row will be 1, 1 and 1. Your first row will be as it is, right? So you can see your second row is same as third row. So we can say your determinant is 0. Ta-da! Option C is your final answer. In this question, we have to find the value of this determinant, which have 10 factorial, 11 factorial, 12 factorial, and so on, so many factorials. So here we are going to use the property of factorial, which says n factorial can be converted into n minus 1 factorial. We can convert 11 factorial into 11 minus 1 factorial, or we can say 10 factorial. Similarly, we can convert 12 factorial into 12 into 11 factorial, or we can say into 10 factorial. So let's use this information in the first row. So here we'll get 10 factorial. Instead of 11 factorial, we can say 11 into 10 factorial and 12 into 11 into 10 factorial. So we can get 10 factorial common in the first row. Now let's convert all the terms of second element into 11 factorial terms. So 11 factorial will be as it is. Instead of 12 factorial, we can say 12 into 11 factorial, then 13 into 12 into 11 factorial. And same way, we can get 12 factorial common in the last row, 12 into 13 into 12, then 14 into 13 into 12 factorial, right? So we can take common 10 factorial from the first row. We can divide 10 factorial with the first row. So we have to multiply 10 factorial with the determinant, and our first row will be 1, 11 and 12 into 11. We can say 132. Same way, we can divide second row by 11 factorial. So we have to multiply 11 factorial with the determinant, and our second row will be 1, 12 and 13 into 12, or we can say 156. And same way, we can divide 12 factorial with the third row. So here we get 12 factorial in multiplication of determinant, 1, 13 and 14 into 13, or we can say 182, right? Now we can expand the determinant, but I think we should further simplify using the last property. Let's try to get 0 at this point using the first row. So our second row will be converted into R2 minus R1. That means you have to multiply minus 1 with the first row and add into the second row. So here we'll get 1 minus 1, 1, 11 minus 1, we'll get minus 11, and 132 minus 1, 132. Okay. Similarly, we can get 0 at third row using operation. R3 gives R3 minus R1. Same way, you have to multiply minus 1 and add into the third row. So we get minus 1, minus 11 and minus 132. So in this step, our 10 factorial, 11 factorial and 12 factorial will be as it is, and our first row will be as it is, right? And our second row will be changed as 1 minus 1, 0, 12 minus 1, 1, and 156 minus 132 will give us 24, and the last row will be 0, 2, 50. So now we are ready to expand with respect to first column. Our 10 factorial, 11 factorial and 12 factorial will be as it is. The sign of the first column is plus, minus and plus. The elements are 1, 0 and 0 respectively. We don't have to worry about these two zeros and their minus, because 0 into anything will be 0. So minor of the 1 can be obtained by eliminating first row and first column. So now we have to cross multiply. 51s are 50 minus 2 24s are 48 and 0 and 0. So here we'll get 50 minus 48, which is your 2, into 10 factorial, 11 factorial and 12 factorial as your final answer. Ta-da! Option C is your final answer. Let's see our next question. If one of the cube root of 1 is omega, then you have to find the value of this determinant. Now here it is given that omega is the 1 of the cube of 1, and the property of cube root of unity is 1 plus omega square is equal to 0. So we can say 1 plus omega square can be rewrite as minus omega. Now let's use this property in this element. So our first row will be 1. Instead of 1 plus omega square, we can write down minus omega, and omega square will be as it is, and rest of the terms will be as it is. Now before we expand the determinant, let's try to get 0 as much as possible. Let's try to get 0 and this element by taking minus with first row and third row. So we have to take R2 gives R2 minus R1 and minus R3. So let's do this. First of all, multiply minus 1 with first row and add into the second row. So here we'll get minus 1, then plus omega and minus omega square. Now let's multiply third row with minus 1 and add into the second row. So here we'll get plus I, then plus 1 and minus omega and plus 1. So our first and third row will be as it is, and our second row will be 1 cancel, I plus I will cancel, get 0. Same way minus 1 plus 1, omega minus 1, get another 0, omega square minus 1 plus 1 and another 0. So our entire second row is 0. So the value of determinant is also 0. Tada! Option D is the final answer. Let's see the next question. If ABC are all different terms and this determinant is equal to 0, then you have to find the value of A into B into C into AB plus BC plus CA. And for that, let's simplify our determinant. First of all, I am going to expand, or we can say split, our determinant with respect to third column. That means our first two columns will be as it is in two determinants. We have to split the terms of third column, A raised to 4 and minus 1, then B raised to 4 minus 1, finally C raised to 4 and minus 1 is equal to 0. Now in first determinant, we can divide first row by A. So we have to multiply whole determinant by A, and our first row will be 1 A square and A cube. Similarly, second row can be divided by B. So we have to multiply by B, and second row will be 1 B square and B cube. And same way with the third row divided by C, we will get 1 C square and C cube. Now in second determinant, let's interchange first with the third. So your third will become your first row and your first will become your third. And due to this operation, you have to change the sign of the determinant. Let's do this operation again. Let's interchange second row and the third. So this third will be your second, and this second row will be your new third. And due to this operation, again we have to change the sign, right? In next step, our first determinant will be as it is, plus we can take minus common from the first column. So let's multiply minus 1 with the first column. So this will become minus 1, and our first column will be 1, 1 and 1. Rest of the columns will be as it is. Now here I am going to use the values of this standard determinant D1, which is equal to A minus B, B minus C, C minus A into AB plus BC plus CA, and D2, which is equal to A minus B, B minus C, C minus A and A plus B plus C. So let's put the value of B1. So this ABC will be as it is, and here we will get A minus B, B minus C, C minus A in the AB plus BC plus C minus the value of D2, which is equal to A minus B, B minus C and C minus A into A plus B plus C. Put over here is equal to 0. So here let's take A minus B, B minus C and C minus A common from the two terms. So from first term, remaining terms are ABC, AB plus BC plus CA minus from the second term we will get A plus B plus C is equal to 0. Now in question it is given that A is not equal to B not equal to C. So these three terms must not be equal to 0. So we can say ABC into AB plus BC plus CA minus A plus B plus C must be equal to 0, or we can say A into B into C in the bracket AB plus is equal to A plus B plus C. Ta-da! This is what we want. So option A is your final answer. Interesting question. You to find the solution of this determinant equation, in which we have summation of two determinants, right side B, another third determinant. If you see carefully, we have two different same rows, these three determinants. So let's try to change on left side, then on right side. First determinant, let's interchange for first and second row. So your first row now become second row, and your second row will become a first row. The third row will be as it is. Due to this operation, we have to change the sign of determinant. Plus become minus. Similarly, let's try to change first and third row, second determinant. So your first row will become your third row, and your third row now becomes your first row. Second row will remain as it is. Here you have to change the sign of the determinant. Plus will become minus, and your right hand side will remain as it is. Now, let's remember summation of two determinants, which two rows must be equal to each other and they will remain as it is. In this case, our first and third row will be remain as it is, and here to add second row, here we'll get minus x and minus 6. Next element minus 4, minus 4. Last element 6 minus 5. Our right hand side will remain as it is. By comparing left hand side and right hand side, get same quantities 2, minus 8, minus 8, minus 11, minus 8. So we can say minus x minus 6 is equal to 2x minus 1, which will give us x is equal to minus 5 by 3. Ta-da! Option A is your final answer.